Hello, and welcome to my talk, Introduction to WebSocket with Spring Framework 4.0. This presentation is available online. It is an HTML-based presentation, and I will provide this link with the slide materials. You can also copy it down. I'll bring it up again towards the end. What this talk is going to be about. WebSocket is a very broad subject area. In this presentation, we're going to focus on introducing it as a technology. We're going to mention briefly what it is, what you can do with it, and also we'll primarily focus on Spring Framework support for that, which is now available, comprehensive support. I should mention, though, that, as I said, it is a broad subject, but also it is when you decide to go beyond a hello world application, you really sort of go off in a direction that goes a layer above WebSocket. So if you're actually planning to build applications in a browser, I recommend highly that you attend my next presentation, which is going to be in the neighboring room, 209, 210. This presentation is here because WebSocket is what we're building on, and it is an exciting new capability. So we have to satisfy our curiosity. We have to understand it on that level first, and then move up a level. And this is the next talk. What is WebSocket? Let's get right into it. Essentially, it is a mechanism for browsers and servers to communicate with each other in a way that wasn't possible before. It is, in fact, a two-way communication between a browser and a server, and it doesn't rely on multiple HTTP connections. I was looking for an image to represent something really hopeful and something really kind of inspiring, and this is what I came up with, and I'm glad it fit the whole screen. It is an exciting new technology. It is bringing a lot of interest. It's a buzzword, I would say, at this point. And this excitement, I would say, is justified given that we have a relatively long history by now using HTTP and trying to push the boundaries of HTTP with, first coming up with AJAX, making pages more dynamic, and then using various comment techniques in order to achieve various degrees of liveness within the browser. However, with this new capability have come expectations, and I myself have gone down through that path of basically thinking about it in a certain way, but then those expectations come a little bit ahead of experience. Once you get your head around it, once you start using it, you begin to realize that there's actually quite a bit more than is apparent initially. So here are just a few, I would say, false expectations, to varying degrees false, that you might have when you approach this. First of all, WebSocket is a standard, so it probably works everywhere, right? We can start using it. Another expectation is that we are going to use that as a complete replacement of AJAX and Comet. This is a reasonable expectation, of course, but as we'll discuss, there are specific use cases where WebSocket is a really good fit, and then there's other cases where what we've been using actually is simple and continues to work quite well. So I would recommend against kind of seeing it an either-or proposition. There's even been excitement to the point of actually saying, is this going to replace what we're doing now? Is this going to somehow magically remove the need for REST? You can breathe a sigh of relief if you've invested a lot of time in learning in REST. That's not really the case. I have included a link with a discussion on InfoQ on this subject. I think they're very much complementary. I think WebSocket technology enables us to do something new, but it doesn't really replace what we've been doing and what has helped us to scale the web to this point. Yet another expectation is that we're familiar with web applications. We've been doing web applications for a long time, And now we're going to start using WebSocket. Well, it's really, kind of like learning the Ajax commit technique. It's pretty much in the same domain of things. It actually puts us on a path to a different architecture, as we will discuss here a little bit, but much more in the next presentation. And then the last one is kind of very ironic. The expectation is that you will actually program into a WebSocket API. I would actually contend that the majority of applications will probably not benefit from using directly the any WebSocket API. And the reason for that is because the WebSocket API is on a very, very low level. Essentially, you're just slightly above TCP with, instead of getting a stream of bytes, you're getting a stream of messages, but it's still very, very low level, and it's once you start using it, you end up building a lot of infrastructure around it in order to actually start to do meaningful things with your application. So I kind of mentioned some of these things already, but let's go through the list. First of all, in terms of support standards, well, Internet Explorer is a pretty big factor for any public-facing application. Anything less than Internet Explorer 10, which is pretty much all browsers out there, is not going to support WebSocket yet. There are some issues with proxies because WebSocket is a standard and it's actually doing something completely new. Existing proxies may not be configured to actually allow it or to understand it, which means that they may actually either not allow the connection to happen, or they may discontinue the connection because they don't think it's HTTP traffic, or they think that it's timing out and it's being open for too long. So there are issues with proxies. It's not only the browser compatibility, but there are network issues with it as well. I mentioned this, it's not a replacement for REST. REST is still a solid foundation for building our applications. I think there are certain categories of applications that are going to benefit much more from WebSocket technologies, the WebSocket protocol, and specifically those are applications that are sending a high number of events back and forth between browser and server. If you think about collaboration applications, or if you think about a financial trading application, or games, those are prime examples where HTTP really pushes the boundary, and it's not really the ideal way to do things. But there are also many categories of applications where the use of WebSocket, there's nothing wrong with it, but it's not, strictly speaking, necessary. If you just need to update the latest story on a page, if you just need to show the latest tweets, that's something that you can do by polling every minute or every 2 minutes, and there's really nothing wrong with doing that. Socket is a very low level to work on. If you take the word web from it and you just talk about programming to sockets, sockets generated excitement some time ago, but if you think about it, not many applications can say that they're actually programming on the socket level. And this is really what we're talking about here. And then the final point to make is that, and it's really quite subtle, it's not so obvious until you actually start doing it, that once you start using WebSocket API or building on WebSocket, you're really kind of shifting over towards a messaging style architecture. And I can't emphasize this enough to make the point that this is quite different from REST. It's really a good idea to kind of leave the expectation behind that it's going to be just like what we've been doing. Once you get into the land of WebSocket, it's basically a messaging architecture, and we really need to adjust the way we think about what it is that we're doing. We actually did a talk last year at this conference. That was Chris Beams, Gunnar Hiller, and myself, and we basically explored this subject. And it's kind of interesting to see how much has happened over the course of the last year in terms of, if you're tracking the developments with servlet containers and where the support for WebSocket has come. We've really come a long way. And also, of course, in the Spring Framework, we've come a long way. But basically, last year, we did an exploration of this topic to see where we're at. It's kind of a broad, pragmatic introduction. It's kind of a survey of the landscape. And really, it was more about defining questions. You know, the more we looked into it, the more questions we defined, and there were no obvious answers. There were no clear answers at the time. So that's basically what the talk was about. Some of the key takeaways that we finished with were that the need for fallback options will persist. And fallback options means that if WebSocket is not working for any reason, your browser is not supporting it, or there are network issues, you need some sort of a fallback option to fill in transparently. Integrating into real applications, not yet trivial for a number of reasons. First of all, the container support wasn't, well, it was there, but it wasn't yet in kind of a stable, in a long-term sense fashion. As you will see, a lot of the servlet containers have actually completely revamped their WebSocket support since last year. But hopefully now we're on a path where this is going to last us longer. And there's lots of other questions around building real applications. Again, this is going to be covered in detail in my next presentation. We also mentioned that pure WebSocket applications in the wild are just not frequent. I mean, if you are in the habit to look at what an application is actually doing sometimes in the browser, it's kind of one of those professional habits. What are they doing? Look in the network traffic and inspect what's going back and forth. It's really not easy to come across websites that are actually using WebSocket by default. Lastly, there are many questions that remain around usage patterns. I mean, we really need to take a step back basically from all this and say, what are we actually trying to do? WebSockets is a means to an end. It's a very cool new capability, but ultimately, what is it that we're trying to achieve? That's really the most important question. Because once we look at that question, WebSocket can become a bit more of a transport layer detail, and we need to focus on the usage patterns, what it is that we're trying to achieve, and how can we actually do that. So with that introduction, let's do a quick definition of WebSocket. It's not going to be anything in-depth. There's really actually not enough time for that. But hopefully I can give you a sufficient feel for what WebSocket is if you haven't spent enough time with it yet. Essentially, it is a layer, a very thin layer on top of TCP. You're opening a TCP connection fundamentally, and then you're using it to communicate back and forth. It is a stateful connection. Once it's opened, it stays open for the duration of that session. And it is full duplex, meaning that we can send messages back and forth. And this is really the critical key new capability that we're getting, which we didn't have before and could only simulate. We're getting a stream of messages, so we're slightly above TCP. We're not just getting a stream of bytes. And we are going to be using HTTP only for the initial handshake. So the only relationship of WebSocket to HTTP is that initial handshake, which allows us to go through firewalls and basically use the existing infrastructure, and browser applications can connect to a server, and then the server will do a switch, and now they're going to start talking on that TCP connection. So this is an example of a handshake request. You can see here that it's a regular HTTP request. It's a GET. We are going to also specify some additional headers here. You'll see the upgrade and connection headers, which are using the upgrade mechanism built into the HTTP protocol to request to switch from HTTP to WebSocket communication. There's a few other things built into it. You will see that there's a protocol header, and that allows the browser and the server to negotiate a higher level protocol that they can use. So just like HTTP is a protocol above TCP, with WebSocket the idea is that you can use something above it, and client and server can negotiate what that should be. There is a cross-origin support built into the protocol. You will see the origin header at the bottom. This is something that browsers automatically submit, and you can't really touch that. The idea is that this is kind of built into the protocol, this kind of protection. And there's a WebSocket key as well, which is used to ensure that the server is not responding by mistake to this WebSocket communication. The server has to respond with a equivalent key, which has done some hashing of that key. And then you can see the response. The status is 101. We're agreeing to switch the protocols. And all the other headers are basically required. You'll see the protocol header at the bottom, which is where the server has accepted the proposed higher level protocol. And there's also the accept key, which ensures that the server is actually intentionally responding in this way. After this initial HTTP handshake request, we're going to start exchanging messages on this socket, and that's really what goes on from here on. If you look at most APIs, typical lifecycle events are we've opened the session, so now we have a session available. It's a stateful protocol. We can start getting messages to arrive. There can be a transport level error that can occur, and we get notified through a callback. And there's also a close callback, which is when the session is actually terminated. Typically, error and close come together. If one occurs, the other one will happen as well. And the close has a status. There's a bunch of status codes that are associated with the close that can indicate what was the reason for that closure. And it's interesting that the client and server APIs are completely symmetrical. So whatever you see on the server side is actually the same API that is going to be on the client side. This is an example WebSocket frame. For the most part, you don't really need to understand the details of all of that, but probably the key thing to point out here is that primarily we're carrying some kind of a payload. A WebSocket message can be split into multiple frames. So this is just one frame, but there can be others to come. There's an opcode that you can see over here, and that's going to indicate what kind of message we have. If you're using a network sniffing tool like Wireshark or something on that level of TCP, then this is probably something that's going to be relevant to understand. Like, for example, the first byte here, fin indicates if this is the final frame, etc. So you may need to look at this if you're on that low level, but for the most part, this is not something you should have to be concerned about. So what kind of payloads messages can have? We can have text messages, which are interpreted as UTF-8 text. We can have binary messages that are up to the application to interpret, however it sees fit. And these are really the two main kinds of messages that we have. Beyond that, we have control frames, and those are single frames that indicate that the connection is being closed. There's also a ping pong control frames that a client can send a ping frame to the server which basically obliges the server to respond with a Pong message, which browsers can use to ensure that the server is still there. It's also possible for the server to send the unsolicited Pong to the client periodically. There's also continuation frames. I mentioned that a message can be split into multiple frames. And in terms of message versus frame, this is one of the major changes that have occurred in the APIs of the servlet containers from last year to this year. I'll talk about the JSR-356 discussions, but basically one of the outcomes was that it was agreed that frames are kind of a lower level concern, something kind of like chunking in HTTP. Something that you don't normally see. Typically, you will receive in the API a message which can arrive through multiple frames, and a lot of the APIs actually don't even expose frames directly. The other reason not to consider working with frames directly on the application level is that the WebSocket protocol has a number of extensions. A lot of them are still in the works, but for example, there's a multiplexing extension which can ensure that multiple clients can connect over a single connection. And also there are other optimization type extensions which can reorder frames on the client and server side. So for this reason, you can see that it's actually not a good idea to try to interpret those within the application. It's better to work on a higher level with messages. So that's typically going to be a detail that the protocol implementation deals with. But it's good to know if you're tracing traffic, if you run into issues, you're going to have to look at some of those messages. Okay, so this gets us to runtime support. This is an important question. What can we run this on? The big news in this area is that we have the Java API for WebSocket, which has become final since last year. This time, there were still discussions that were fairly early on. But now it's all complete, and implementations are hard at work to provide the actual new versions of the respective containers. But several of the servlet containers that supported WebSocket actually predated JSR-356. In other words, they had WebSocket support already. That includes Jetty 7 and 8. That includes Tomcat 7. Some of you may be using those versions, or Glassfish 3. Anybody using any of these versions in applications today? Quite a few hands, yeah. As a result of a lot of debate on JSR-356 expert group, a lot of these APIs, which tended to be sort of, early versions in some ways, they were exploring what to do with WebSocket and what kind of APIs to provide. Their experiences, they basically brought together in those discussions, and there was really quite a bit ground that was covered. It is a very broad subject, not only from our point of view on the application level, but just on the level of WebSocket runtime implementations. The way I see it, one of the major benefits of JSR-356 was to have those containers come together and discuss WebSocket implementation details and come together sort of in a type of convergence with each other, so that not only there's a common API, but there's also a common way of understanding and thinking about how to provide such an implementation. And as a result, not surprisingly, absolutely all of these containers have completely revamped WebSocket implementations. We'll talk about the actual versions in a moment. What's the relationship to the servlet spec? Actually, the WebSocket specification originally started out as discussions in the servlet spec. And very soon it was realized that it's not going to work out because, first of all, WebSocket is client and server side. And when you're on the client side, obviously there's no servlet API there, or at least we can't make that assumption. Very quickly it was separated out as a different spec. Basically JSR-356 has no hard dependency on servlet specification, but it was pretty much done with the participation and for the benefit of servlet containers. Which means that there will be some subtle assumptions in various areas based on how servlet containers work. It wasn't intended to be limited to servlet containers, but I think practically speaking, I don't know yet of any containers outside of servlet containers that are providing JSR-356 support yet. So what's the actual relationship there? After all, we do need to run WebSocket on servlet container. Servlet 3.1 you're going to need. That's part of Java EE 7, and it has a hook that WebSocket engines can use. That's available in the HTTP servlet request, which has an upgrade method that accepts an upgrade handler. And that's really something the WebSocket engines or servlet containers use. The other touch point is there's a servlet container initializer. Essentially, that means a class path scan is going to take place. That's what the specification kind of mandates. If you're running in a servlet container, that this is going to be done. The endpoints are going to be discovered through a servlet container initializer. That's kind of built into the mechanism. And if you're not in a servlet container, if it's an implementation that's outside of servlet containers, then it's basically not defined. It can be done in any way. So what kind of versions are we looking at? First of all, we have Tomcat 8, which is at the moment in version RC1. But I will recommend actually running with snapshots, because at this point it's quite quickly evolving, and RC1 is now a bit old in terms of how much the code base has evolved. We can expect an RC2, and it's kind of unfortunate we didn't get it before this conference, but essentially there's a dependency there that Tomcat itself is waiting on in order to make it happen. But the exciting part is that once we have an RC2, immediately after, this is going to be backported to Tomcat 7. And this is exciting for all of us who are going to build new applications, but if you have an existing application, you may not be so excited because you have to make changes. But basically, the existing Tomcat 7 support is going to go out, and the Tomcat 8 JSR-356 based support is going to go in, be backported to Tomcat 7. Question? Yes?
Yes, the question I have, in Jürgen Haller's talk on Spring 4.0 and Java 8, he said that Spring 4 has Servlet 3.0 in it. So will Spring 4 support WebSockets?
So the question is, Spring 4 is going to have Servlet 3.0 support. Are we going to support WebSocket? Yes, we're going to support WebSocket. If you're using WebSocket, obviously that's going to require you to use a Servlet 3.1 container. And in particular, if we're talking about Tomcat, we're talking about Tomcat 8, but also Tomcat 7 is going to work as well. I actually don't know the exact details of whether they will backport all of the Servlet 3.1 code in, but they're going to make it happen. Basically, this is going to run also on Tomcat 7 pretty soon, probably in a matter of a week or two. Jetty 9 has native WebSocket API support, so the approach here is slightly different. Essentially, they have revamped their WebSocket support completely. It's brand new, has nothing to do with Jetty 7 or 8. But it is their own WebSocket API. It is very closely mirroring the JSR-356. It's influenced by it. It comes as a result of those discussions. And Jetty 9.1, which is upcoming, is going to have the JSR-356 support that's going to be layered on top of what they already provide. Glassfish 4, which is version of GA, it's a GA version. It has the Tyrus WebSocket engine in it. So it's available there as well, and there will be more containers to follow for sure. Now, what about the JSR-356 API? There are two main options if you look at the API. One of them is to extend this abstract base class called endpoint, and the other one is to use annotations. There's an add server endpoint and add client endpoint annotations that then further allow you to have annotated methods for receiving messages. It's pretty much the callbacks that I showed you earlier: on message, on start, on close, on error. That's these four. So it's still pretty rudimentary. In terms of deployment, the JSR-356 style deployment, there are also two main options. One of them is that the servlet container will scan the class path. And when I say scan the class path, I mean every jar, everything that's on the class path. So that's a fairly heavyweight scan there. There's also a programmatic deployment option at startup. You obtain an instance of a WebSocket container, and then you can say, I think it was register endpoint or add endpoint. That basically allows you to use something like a servlet context listener, and during the startup of the container, you can actually explicitly register your endpoints instead of relying on the scan. In theory, you should be able to turn off the container scan. This is a feature which is not known very well because it's actually named slightly differently. There's an ordering element that you can use in WebXML, and that allows you to turn off specific servlet container initializers. But in practice, from my experience, not all container WebSocket support actually works if you turn off that servlet container initializer. In theory, it shouldn't depend on it, but if you turn it off, it doesn't work in all containers. In terms of Spring support, it's what you would expect. You can actually have your endpoints initialized by Spring, instantiated and dependency injected. We have a server endpoint exporter. If you're familiar with Spring in other areas like JaxWS and other areas, this is going to sound familiar. Essentially, it's going to discover Spring beans and it's going to deploy them, beans of type server endpoint registration. Or if you're using annotations, you can register through an attribute of server endpoint a Spring configurator. It's not a very obvious way to do things, but it is the JSR-356 way. Basically, we fit into what the API provides. So you can check out the Java doc of these classes. I've provided links. Basically, they have examples of what you need to put together in order to make it work. Now, let's talk about limitations. Using JSR-356. First of all, there's no fallback options. The expert group discussions, this was basically outside the scope of the spec in many ways. That's understandable. The spec was focused on making sure that we have a WebSocket environment. But in practice, if you're actually going to run applications, the fact that they won't run in Internet Explorer, the fact that they will have issues with proxies is a pretty significant challenge, a pretty significant issue, which unfortunately was not in scope for the discussions. There's no sub-protocol support, which means that it's going to be difficult to build real-world applications. Again, if you go beyond the hello world, working with a socket and blank messages is going to be a difficult proposition. There's no way to handle both HTTP and WebSocket requests from a single place. So if you want to write a single servlet, like a front controller pattern, you can't do that. You have to deploy a WebSocket endpoint, and you have to do it at startup. You can't at runtime say, this request is coming in, it's going to be a WebSocket request, let's start the handshake. And there is actually a link which I've provided to give you some more detail on that. It's actually a link to an issue on the JSR spec. Yeah, this one has some pretty important implications, as we will see. Also, this is a bit a matter of opinion, but JSR-356, in my opinion, resembles application framework more so than a flexible foundation that frameworks can build on. This has been sort of my experience with it. And let's talk about why frameworks actually matter. First of all, if you're going to maintain one WebSocket per client, we're talking about one physical WebSocket per client, that kind of makes sense. You really want one pipeline for all your messages. You don't want to have to open a new WebSocket every time you want to send different kinds of messages. You end up with a single server endpoint per application. That doesn't sound very good, does it? It is very, very rudimentary. And it is very much reminiscent of the relationship between a servlet and a web framework. As you know, most web frameworks are built on a servlet. They use the front controller. If we were to build our web applications with servlets, you can imagine the path that we're going down. We're going to say, if it's do get, then do one of those things. If it's do post, do one of those things. But we're all used to working on a much higher level. We're going to have annotated methods that say, this controller is going to handle requests for accounts, this controller is going to handle requests for portfolios, and so on and so on. With WebSocket, we're in a lower level. Without making any assumptions about what's in the message, we have nothing else to go by. It's just a blank message and an initial URL. So this is why, if you go down that path, essentially you will end up building infrastructure. And this is why I think the JSR-356 should focus on being flexible foundation for frameworks to build on, because it's necessary to provide further infrastructure. I mean, as soon as you go down that path, that's basically what you realize. And I actually came across one user's post on the Jetty mailing lists that I liked, and actually kind of fits what I've been thinking about all of this, where he basically says that using annotations and things is clearly in the vein of frameworks like Spring and Hibernate, but when trying to build on top of it, I find myself wishing for an API more like Jetty 8, where I could just implement some interfaces and build my own abstractions on top of WebSocket. And of course, here he's talking about Jetty 8 versus Jetty 9, but Jetty 9 is very much built with JSR-356 in mind. Okay, so this brings us to the second half of our talk. This is where we actually start to talk about the Spring WebSocket API. So our own API is basically an abstraction over WebSocket runtimes. It allows you to build WebSocket applications and abstract the runtime that you're on underneath. And that includes JSR-356 containers. So if you're running on Tomcat 8 or JD9, those are supported. But it's not necessarily limited to containers that are built on JSR-356. For example, I mentioned that JD9 has a native WebSocket API, and that's something that we use. There's also experimental netty support. This is not something which is actually committed in the master branch, but it's there in the works to kind of as a proof of concept. And this is going to be one of the major differences, that basically we support fallback options. That means you can start building your WebSocket applications today, and if you're running in a browser that doesn't support it yet, there's going to be transparent fallback based on the SockJS protocol, and that's something that we're going to focus on in a little bit. There's a new Spring WebSocket module. That's where all of this is. And this is an example of the WebSocket API. Essentially, we have a method here to handle a message, an incoming message, and then we're going to echo it back. This is the Java configuration required. We're going to use the enable WebSocket annotation, and we're going to register a particular WebSocket handler that we saw on the previous page against the URL of /echo. So essentially what this means is that the client can now open a WebSocket connection against /echo, which is going to go through the HTTP handshake, and then is going to essentially start exchanging messages back and forth. Some of the extra things that we provide with our API, we have the notion of handshake interceptors. They give you access to the handshake request and response, kind of before and after style. You can actually preclude the handshake from taking place. You can return false. Also, you can pass handshake attributes to the WebSocket session. So we have an HTTP interaction initially, then we have a WebSocket session. And for example, one of the things you may want to do is you may want to pass HTTP session attributes into the WebSocket session so that you can have access to that. And there is an example out-of-the-box interceptor called HTTP Session Handshake Interceptor, and either copies all of the session attributes or allows you to specify some patterns so that you can have a subset of them copied to the WebSocket session. There's also a WebSocketHandlerDecorator, which comes convenient in a variety of ways. For example, we have an exception and a logging WebSocketHandlerDecorator. What the exception decorator does is if there's any untrapped exceptions from the WebSocket handler, it'll automatically close the connection and clean up. This is one difference actually from subtle difference from JSR-356, which doesn't allow you to declare an exception on method signatures. We allow you to put them there, but encourage actually handling those exceptions within the methods because that's the best place to deal with them. And these two decorators are applied by default. Another example of something we provide in the API, so you can use a WebSocket handler which is a singleton. It's going to handle all incoming WebSocket connections from clients. But what if you wanted to build a handler which has different kind of semantics, where you're using a new instance for every incoming client, for every incoming WebSocket session? So for that, we provide a PerConnectionWebsocketHandler wrapper that you can just provide with the type of your handler. And then as new connections come, it will create a new instance, do the dependency injection, and all of that, essentially giving you per-connection semantics. Some important notes on URL mapping. So we actually don't use the JSR-356 deployment mechanism to make all of this happen. And the major reason for that is because we want to enable flexible handling of requests, so you can do both HTTP and WebSocket traffic. So for example, if you wanted to map your WebSocket handler using kind of Spring MVC facilities or any other web framework, we want that to be a good foundation to be able to do something like that. We find that this is something missing from JSR-356. And it does mean that we need to do container-specific request upgrade strategy we need specific implementations of those classes. And at the moment, we support Tomcat, Jetty, and Glassfish because those are the ones that have actually available WebSocket support. And there is a ticket which is in the WebSocket specification. I think there is a maintenance spec release towards the end of this year, so I'm hopeful that some changes will be coming from there as well. But at least on the Tomcat side of things, there's already an upgrade mechanism that is provided by Tomcat. It's not part of JSR-356, but it's an API that we can use in order to kind of dynamically invoke get around this issue, basically. Jetty, of course, provides that, and it's another interesting note on this subject is that if you look at all the previous APIs, they all support this in their prior versions. It's just something that JSR-356 didn't have. What about on the client side? So if you want to run something on the client side, we have a programmatic handshake possible through WebSocket client, which returns a listenable future. Listenable future is actually a new type which is available in the Core Spring framework. It's used from the async REST template that some of you may have seen that we now have. It basically gives you access to a WebSocket session in feature style, callback style. You can also start in declarative mode. This is important actually because if you're doing client side, often what you'll find is that when the application starts, you also want to start WebSocket communication automatically. Maybe connect to a server and start pulling some data from a remote source. So you have the option to do that, and here's an example of it. We're going to create a bean called WebSocket Connection Manager, and we're going to give it a WebSocket handler to handle the actual messages. We're going to give it the URL, and then also we're going to use a standard WebSocket client, which is based on JSR-356. And then we're going to set the auto startup property to true, which means that as soon as the application starts, the WebSocket connection will be automatically opened. We're going to start exchanging messages. So for example, last year in our demo, we used an example called Bitcoin that was pulling transactions, Bitcoin transactions from a remote server. So the server was actually acting as a client to a Bitcoin source of transactions. And so we found ourselves in a situation where we wanted this to automatically start as soon as the application starts, start pulling the transactions, then push them down to the client. So that's something that now is kind of nicely integrated into Spring. Comparing to the JSR-356 API, there's only a programmatic version available. There's no kind of automatic startup option. Right, so we get to SockJS support. What's SockJS in a nutshell? Actually, let me take a break here and switch over to give you some idea about this in an example. So we're going to go to okay, so this is a little sample application, kind of a hello world type, echo, and there's also a snake. These are samples that are actually originating from the Tomcat distribution, but basically have been adapted to use our API. Question? Sure, sorry. How's that? Still small. Is that better? Okay. All right. So we have the enable WebSocket annotation. And you can see that in this case, we're doing it on the same class, which is also serving as our Spring MVC configuration. That's the enable web MVC. We're implementing an interface called WebSocket Configurer, which gives us kind of callback methods that allows us to configure kind of the WebSocket endpoints that we want to have. And in this case, we're going to have something exposed on the /echo. It's going to be an echo WebSocket handler, and we can take a look at that, which is right here. And it's a pretty simple class which will take a text message and then we'll actually echo it back using an echo service. And that's really just a very simple exercise in dependency injection. The echo service is just going to prepend it with some kind of a prefix. And then we're going to send that message back. So that's really all we're doing. You can see here that's the echo service. That's the prefix that it's going to use. And then the SockJS part, we're going to leave that aside for now. Let's go over to the command line. And this is where the sample is. And once again, we want a bigger font here. Okay. So we're going to do Maven JD run. And we could use Tomcat as well or Glassfish. So I'll switch among them at some point. And then we can go over to a browser and say localhost and go to our test application. Okay, so we have two different HTML pages. If we go into the echo page, you'll see here that we have a couple of options, and for the moment we're just going to focus on the WebSocket side of things. We're going to connect directly to a WebSocket, and I'm also going to pull up the network panel at the bottom so we can see the actual traffic. And we're going to say connect, and we can see here some results, but actually it's more interesting in the bottom. It's going to be very small, so you need to trust me about what I see here. And it's basically saying status code of 101. It's switching the protocols. That's the initial handshake. And there's also a second tab called frames, and that allows you to see the WebSocket frames that are going back and forth. So let's go ahead and send a message. We'll do echo message, and then this is what we actually get back. And you have to click on the WebSocket connection again, and then you can hopefully see there's a couple of new lines there. And they show the outgoing message from the client, and then the response coming back from the server. And of course, we can do this more times, and then if we click again, you can see that there are more messages coming back and forth. And you know, we see that on the server side as well, getting logged. And also for the client side, there is an example of that here as well. It's under the test folder. And what we have here is also Java configuration. We're creating a WebSocket connection manager, and we're indicating that we want to auto start it immediately. So as soon as the application comes up, the WebSocket connection will be established. So that's kind of a nice declarative capability. Again, you can use a programmatic option as well, but this is what you want to do in a number of situations. And then we have a simple WebSocket handler. This is on the client side, which basically, after the connection is established, we're going to create the message and then send the message. And then we're going to expect that message to come back, and we're going to print it out and close the session. So kind of a pretty simple example. And you can see here all we're doing is just starting it up. Was there a question? Yeah.
So when you on the browser, when you click that connect, this code get run or what code get run?
Okay, so the question is, when I was in the browser, was this the code that was being executed, or was there something else? In the browser, there's actually, thank you, that's a good question. In the browser, there's actually JavaScript in the HTML. So let's take a look at that, our echo.html page. We didn't take a look at that. Basically, you can see here that there's a new WebSocket being created. This is the JavaScript W3C API, basically. And then we're assigning that to a variable. And then you can see that What we can do with that is we have an on-open callback, we have on-message callback, and then on-close callback. And that's really very similar to what you see in the Java API on the server side. It's basically just these kinds of callbacks around the lifecycle and also for handling events, messages. So the answer is on the browser, we have a JavaScript version, but then you could also do this from Java. So for example, I described last year, we did the Bitcoin. It was a server application that's pushing Bitcoin transactions to browsers, but it's actually getting them from a remote source. So the server acts as a client to some remote URL. So let's run this as a Java application. And you can see that we started the Java WebSocket client automatically, and it connected to that URL and you know, received the message back. And now we can press any key to exit. So that's pretty much it. It's you know, it's pretty straightforward actually. When you look at it from this perspective, it's just a, you know, a lifecycle interface with several callbacks. Okay, so what happens if actually I was running in Internet Explorer? This is where we get to SockJS and fallback options. This is really the more interesting side of things, and practically speaking, something that you will need. So first of all, the goal of SockJS is to emulate the WebSocket API. So you can start developing WebSocket applications, but if WebSocket is not working for any reason, it's going to fall back and use something as close as possible. So for example, we have at least one HTTP streaming protocol per major browser. And of course, streaming is kind of similar in terms of performance to WebSocket because we're not going to be opening and closing HTTP connections. You kind of open one connection and start streaming. We have cross-domain and cookie support to go along with that. And also, if we are in an old browser or behind restrictive proxies that don't allow WebSocket traffic or don't allow streaming traffic, because some of the reasons why proxies don't allow WebSocket is also the reason why they won't allow streaming protocols, because they don't understand them or think that they've been going on for too long. So sometimes we need to fall back to polling as well. And you know, polling can be okay. Actually, a lot of applications, you'll be surprised, if you are using any kind of collaboration app or other online app, take a look at the network tab and see what's going on there. Polling is actually powering a lot of these applications, and it really depends on the frequency of the events. If the events aren't, you know, wildly frequent, it's going to work fine. No flash inside is another important item. And there is a table on the SockJS client page that shows all the different transports by browser. So you can take a look at that. You can see it's pretty comprehensive. I would say that SockJS really is the most ambitious and wide-ranging kind of support for fallback options that are available out there. The way you enable SockJS in Spring is actually pretty trivial. You can see this is pretty much the same example as before, except for the last part with SockJS. This is what's actually going to enable the use of fallback options, and it's all going to be transparent. Everything else remains the same. So for example, what you developed as a WebSocket handler remains exactly the same. There's no need to change anything else. It's primarily a configuration change. And then on the client side, you can see it's the same idea. You create a SockJS socket instead of a WebSocket, but other than that, the API is absolutely identical as much as possible. And that's where we can switch over to the sample again. I will show you that in our configuration, we have two more URLs exposed, and they are configured with SockJS. And I could actually further configure the SockJS here. I can say dot, and then, for example, there's a way to set the heartbeat time. So I can change it, for example, to 30 seconds. And what the heartbeat time is that SockJS on the server side will send heartbeats every 25 seconds in order to make proxies understand that the connection is still alive. Otherwise, they may automatically close it. but it's something that you can change, and by default you just need to enable it. So now, because it's already running, we can just go back here and clear. We'll enable SockJS, and the actual application here gives you a choice to actually force it to say this is the transport you should use. So by default, what it does is it's going to start in a certain order. It's going to go with WebSocket first. It's going to say, is that available? And if that's not available, it's going to go back to the next order. In order of efficiency, what's the next transport? So in order to simulate that here, because it's always going to be WebSocket, well, let's start with WebSocket actually. So we'll connect, and this is too small to see again, but the first line has just the letter O, nothing else, just the letter O. That means open frame. That's kind of the SockJS protocol. It has a little bit of framing around the messages. Then we can send messages, and now if we take a look, we sent a message and then we received the message. And again, what you don't see is that there's a little bit of framing there. There's a JSON array of data. That's basically how the SockJS protocol communicates. It's just a very lightweight framing around the messages. But really what we're interested in is to see what happens when we switch to a different protocol. So let's say XHR streaming. So what happens with streaming is that in order to make this work, we're going to open an HTTP connection to the server, and we're going to leave that open for a long period of time. How long? As long as we fill up a buffer of 128K by default. So if we're sending little messages, that could stay open for quite some time. And the idea is that with HTTP, if you want the server to push data to the client as soon as the data becomes available, you have to have an open connection. You can't send data otherwise. So we're going to keep one connection open for a long time and then push through it. And then if we want the client to send messages, we're going to use HTTP post. So let's go ahead and connect, and you can see that there is an XHR streaming post request, and that's actually open right now. It's continuously running. So now if we send the echo message to the server, there is an XHR send at the bottom. This is also an HTTP post, and that's actually sending the echo message up to the server, and then the server responds to it on the XHR streaming request. So there's two connections open. One is used for sending, the other one is used for receiving messages. This is kind of the nature of fallback options. Interesting side note, if any of you have used the long polling and Servlet 3.0 async support features in the previous version of Spring MVC 3.2, this is kind of a level above that here. We're actually working with a WebSocket API, but underneath it using long polling. We can switch to XHR polling as well, and then you will see a lot more going back and forth. So let me clear. And now if I start echoing messages, each time I echo a message, there's a polling request that finishes, and then there's an XHR send for the next message. So there's a lot more chatter going on. But essentially, our API remains unchanged. What we're doing in our application is absolutely the same. So that's kind of nice. I mean, this is really something you need in order to start using applications today. Okay, so how does this actually work? The SockJS protocol defines a URL scheme, and the actual protocol is defined in the form of a readable test suite. There's a wide support for the SockJS protocol across languages, not just Java. And this is the SockJS URL scheme. We have, for example, a GET request for /echo. Echo is the top-level URL for the endpoint that we want to expose. So this is known as the greeting URL in SockJS. Then we have /echo/info. This is a way for the SockJS client to get some information from the server, like how frequent are the heartbeats, or is WebSocket enabled? So I can actually disable WebSocket from the server side explicitly if, for example, I think that that would be problematic for my application. And I think this is done in some cases. And then we have the most important URL type. That's the post. That's a transport session-based request that includes a server ID, a session ID, and a transport option. So as we make a lot of requests, polling requests, they're going to be identified by their session ID as being part of the same session. And then they're going to have a transport at the end which tells the server, are we doing polling? Are we doing streaming? Are we doing WebSocket protocol, etc. And this is an example interaction. The server begins by, the client begins by sending get request /info, and that responds back and gives some basic information. Then we start a streaming request. That's a HTTP post that's going to be used for sending messages to the client. And then you're going to see a bunch of post requests with XHR send that are used for sending messages from the client to the server. So where will this work? If we run this application, where is it going to work? It's actually going to work in any Servlet 3.0 container. Notice I'm not even mentioning WebSocket here, even if it doesn't support WebSocket yet. So you can take, for example, the current Tomcat 7, which doesn't yet support the JSR-356, or you can take the current JBoss or WebSphere container, anything that supports Servlet 3.0. And you can run this on it. That's the beauty of the fallback options. It's not going to use WebSockets, obviously, but it's going to fall back on HTTP streaming or polling, whatever is available, and it's just going to work. The actual implementation that we have has no hard dependency on the Servlet API. It's kind of a bit of a more forward-looking effort on our side. Since we're creating a brand new module, Spring WebSocket module, we kind of realized that there are cases where we may run this outside of Servlet containers. It's much more obvious. So we're actually building on the HTTP request and response abstractions that are available in Spring Web, not on the Servlet API itself. And as I mentioned, as a proof of concept, we have experimental neti support, which actually works, but it's going to require some more tweaking. Finally, one important subject here, which is client disconnects. This is kind of a topic specific to Servlet containers. So Servlet 3 containers, the async support in Servlet 3 doesn't detect when a client goes away. There's actually no callback in the async support of Servlet 3.0 containers that tells you when a client has gone away. And this is a bit unfortunate because, in fact, we need to know when clients go away because we want to clear their sessions. We have these long polling requests going on. But this actually tends to work out okay in practice because we send periodic heartbeats to the client. And the reason for that is different is because we don't want proxies to kill the connection. But when the heartbeat actually fails because the client has gone away, that's when we realize that the client, either the client has gone away or no matter what happened, there's no reason to keep the session open because we can't send any more messages to the client. Something very basic has failed. So this means that by the next heartbeat, we're going to find out anyway the client has gone away. And I've personally raised this question on the Tomcat mailing list, so you can see a discussion there. It's kind of taking the Servlet capabilities, moving them from the time when they came, from where they came before we had async support, and then now using them for something fundamentally different. We're trying to simulate messaging here within the browser. We have long polling, we have long running requests. So they weren't originally built with that in mind. And it's interesting, if you see that discussion, that the outcome of the discussion is that it's not that the container is not capable of detecting that the client has gone away. It's that the container doesn't really have any convenient point in time to actually report that back to the application. And there is a Servlet Spec issue that's available there. Once again, I consider this to be a pretty important issue for Java server applications. So exercise your vote to make it known that this is an important issue. And the example application that I was showing is available. It's a fairly straightforward kind of hello world app. In my next presentation, which is going to be in the adjacent room, we're going to take a look at a much more sophisticated application that aims to resemble a real world application. It's a stock portfolio application. It has a bunch of situations where we're sending quotes, stock quotes to the browser. We have to subscribe for specific quotes that we're interested in. It has trade requests, execution, and then sending confirmations back to the client, dealing with errors. These are all actual questions and usage patterns that we haven't even touched on, because primarily what we've been talking about is how do we run WebSocket, what's available in terms of WebSocket support, and how do we actually get it to run in all browsers and through network proxy issues. So once we go beyond the hello world, really, I mean, WebSocket and SockJS are very important foundations. It's what's going to allow you to communicate back and forth between browser and server. These are new capabilities that we didn't have before. But we haven't talked about usage patterns, and that's really what the subject of the next session is. So if you're just curious about WebSocket, this session was for you. If you're actually planning to build applications, it's really the next session that's going to give you the answer to that. So thank you. I'm actually glad to be finishing a little bit early and allow some time for questions, because for the next session I'm going to have to move, and otherwise wouldn't have any time. Any questions? Yes? Are you looking at the online calendar or the book? The schedule. The official book does put it in room 209, 210, so I would go there. I think there's a XD presentation here, Spring XD. Any other questions? Yeah, back there. Okay, I actually couldn't hear very well, but I think you mentioned load balancer and client-server connection. Is that right? Yeah. Yeah. You're establishing a connection. Only the initial connection is an HTTP connection. After that, you have a fixed socket communicating between the browser and server. So if you actually lose that connection, you've lost the WebSocket session. But for the duration of the session, that's the connection you're using. So you're fixed to that particular server. Was there another question? Yes, security. Right. We're going to mention that in the next presentation a little bit. But essentially, what you'll see is that in the sample application that we built for the next session, we're using Spring Security to do the authentication just like any web application. Because you're coming over HTTP, that works without any surprises. It's pretty much the same. And then the authenticated user gets transferred onto the WebSocket session. So there's a way to get the principal, the authenticated principal, from the WebSocket session, and that way you know who the WebSocket session belongs to. I also earlier showed a way to copy attributes from the WebSocket, from the HTTP session to the WebSocket session. So these are a couple of mechanisms. But I will say that there are some open questions that remain. So for example, the HTTP and WebSocket sessions have a different duration, different length. So on the one hand, you want to make sure that you may want to, for example, if one finishes, you want the other one to finish as well. That may be something you may want to do in your application. Or you may want to force both of them to finish as well. Or maybe you want to keep the other one running longer because one is running. So if I have, for example, I'm sitting on a page and I'm communicating through WebSocket. If I then click to go on another page, I shouldn't appear to be logged out because I've been using the application, but my HTTP session can expire separately from the WebSocket session. So there's a variety of other scenarios that we're thinking about, and there's going to be a Spring Security release coming later on after the current one, 3.2. So we'll be addressing a lot of these questions there. But what I would say for now is you can do probably like a simple ping every 10-15 minutes to make sure the HTTP session doesn't expire. Or for logging out, you can do things like close the session and then also send a logout URL to the server for the HTTP logout. Things like that. Yeah.
Just to elaborate on that, we're also looking into authorization. So we've done the authentication, but we also need to make sure we tackle that appropriately as well.
Yeah.
There's some other things that
Yeah, so authorization is another important subject, and it's an interesting topic there that what we're authorizing is actually the sending of messages. And so we need to identify what messages are for, who they're for. So this is another reason why we need something above WebSocket. And you'll see in the next session, we'll talk also about, we're introducing some of the Spring integration types like message and message channel. And there we have some opportunities to introduce like channel interceptors and then authenticate based on message destinations and things like that.
So if your HTTP is using HTTPS,
Mm-hmm.
what happens with your WebSocket connections? That those possibly be some sort of, I don't know, cannot be HTTPS, right? SSL.
Yeah, so there is WSS scheme as well for the WebSocket protocol, and you can use that. It's actually recommended to use that instead of just WS because it prevents proxies from trying to see what's inside the traffic and to realize this is not HTTP traffic. So you can actually use WSS as well, secure WebSocket. Well, it's the URL that you're initiating from the client side. So it's kind of like HTTPS basically. When you initiate it, you have to specify which one you want to use. You don't need to change your code, right? This is kind of an implementation detail, right? Yes?
You mentioned that the message can span frames. Who does the aggregating?
Okay, so the question is a message can be broken down into frames. Who is aggregating the frames? That is the job of the implementation, the WebSocket engine. And it can also be done through WebSocket extensions, which are, again, configured into the WebSocket engine implementation. So actually, the protocol allows for the client and server to negotiate which extensions should be used. But ultimately, it's a low-level detail that's part of the WebSocket server rather than the application's job. It's actually recommended for the application not to be on that level because there could be a lot more going on than we realize there, and it's better to let them kind of do that, and we work on the level of messages rather than frames. Okay, going once, twice. Oh, one more.
I was going to ask if this is already in GitHub and if there is any production application that is already using this, let's say in Spring.io, for example.
It is on GitHub, yes. It is in the master branch. We've been through a couple of actually 3 milestones. We're going to have a release candidate coming up in 2 or 3 weeks maybe. So definitely it's there. You can use this code. Actually, we're running our samples. In terms of being in production, no. There's, to my knowledge, nobody's running in production. I hope nobody's running in production with it yet, to be honest. But it's getting there. It's actually a very good time to be looking at it. If you have a specific use case in mind, this is actually a very good time because it's a lot of new things. And if you try it and you find, well, this doesn't really match to what I'm thinking about doing, that can actually influence at the moment very significantly what we're doing still.
So we've kind of played with using Vertex on the server side or degradation server side and SockJS on the client.
Mm-hmm.
Would this be a good easy swap server side?
Yeah, so the question is, if you're using Vertex right now with SockJS support, is this easy swap? It aims to provide the same capabilities, absolutely. Will it be an easy swap? It probably depends in part to the extent of your application and what exactly you're doing. I would say that actually Vertex, what Vertex provides is very much on the level of WebSocket. It allows you to exchange messages, but it gives you an event bus. on top of that, so you can actually tag a message with a specific event. So it allows you, it gives you this kind of delegation model. In the next presentation, we'll talk about our stomp-based support, which is actually, I would say, a level above that, that gives you support for messaging patterns like publish, subscribe. It allows you to integrate a message broker on the server side, like RabbitMQ or ActiveMQ. And it also allows you to have annotated methods based on destinations. There's a destination header in Stomp that allows you to understand who this message is for and what does it mean. So I would say actually that we will provide you with probably more facilities than what you will find. But that said, you know, it really depends on what you're doing concretely. I would recommend actually exploring that path to see. And I'll be around also if you want to talk to me a little bit more afterwards. Yes? Okay, I think I heard it. WebSocket performance compared to HTTP, traditional HTTP requests. You know, again, it's going to come down to what exactly the application is doing, but the way it kind of falls down is that the more frequently client and server, browser and server are exchanging messages, the more traditional techniques like long polling become you know, very inefficient. So if the long polling happens once every 2 or 3 seconds and that gives you real-time behavior in the browser, you know, that's not so bad. But if you start streaming messages in milliseconds, that's really, and if they're larger in size, that's going to impact the performance in quite a bit. Okay, well, thanks very much, and hope to see you at the next presentation.